I've covered Blue Origin, or Blue for short, many times on this channel. Topics have included their lunar landers, the cislunar transporter, their vision for humanity's expansion into space, and their upgraded New Glenn super heavy lift vehicle. Today, I'm going to look in detail at their ISRU plans. ISRU stands for In-Situ Resource Utilisation, or NASA's term for living off the land. The idea is to use local resources on the moon to produce useful materials to offset the need for expensive Earth resupply missions. This is a key step in NASA's moon-based plans. Blue Origin, perhaps more than any other company, has developed the essential technologies and hardware to turn this idea into a reality. After explaining their approach, I'll give my own thoughts on their vision for developing the moon. As always, drop your own thoughts and opinions on Blue's ISRU plans in the comments, and we'll discuss at the weekly livestream every Saturday. Blue Alchemist is the term the company uses to cover their lunar soil processing hardware and technologies. Let's begin with how they plan to process the lunar soil. Blue's DARPA LunA-10 submission for a fast commercial lunar surface architecture. Blue Origin submitted a proposal to DARPA as part of their LunA-10 study, outlining how to quickly build a commercial lunar economy. The company identified several resources that can be extracted from lunar regolith: oxygen, iron, silicon, aluminium, and construction slag. From these lunar-derived materials, they envision manufacturing solar panels, wires, radiators, radiation shielding, road surfaces, and propellants. Their three-step plan begins with landing an infrastructure node on the surface. The first Blue Origin Mark I cargo lander is scheduled to fly later in 2026. Step 2 involves deploying a laser power and communications framework. I previously covered Honeybee Robotics lunar masts, which can support power generation, communications, and more. Honeybee Robotics is owned by Blue Origin, giving the company ready access to hardware for large-scale power deployment on the moon. The largest variant of Honeybee's lunar masts stands 100 meters tall and can beam power to distances of 20 kilometers or more. Reliable power generation and distribution will be essential for processing of lunar soil at scale. And finally, the third step is excavating and processing lunar soil by melting the regolith and extracting useful materials. This requires a great deal of power, which is why it's the third step after power infrastructure has been established. In graphics from the DARPA submission, Blue Origin's ISRU plant produces slag, metals, and oxygen in both gaseous and liquid form. The liquid oxygen can be used to refill the tanks of Blue's Mark II lunar lander or vehicles such as SpaceX's Starship. Gaseous oxygen could supply fuel cell systems, for example those from Sierra Space or Honda. Metals could be supplied to partners such as cislunar industries for lunar forging, while slag could be used for constructing roads or landing pads. Iron from the ISRU plant could also support a lunar rail network, as envisioned by Northrop Grumman. Check out my video on their lunar rail plans. Blue has plans for an initial demo of their ISRU technology on a Mark I cargo lander. The plan is to land a power and communications payload kit consisting of a vertical solar array tower, power storage for lunar nights, laser power beaming, and radio and optical communications. A silicon extraction experiment using molten regolith electrolysis will be deployed. Silicon extracted this way can be used to manufacture solar panels. Adding oxygen to silicon produces glass, which is useful for protecting solar panels or for windows in lunar habitats. The proposed initial demonstration system is quite capable. It includes beaming 1 kilowatt of power over 10 kilometers or more, delivering 7.8 kilowatts of continuous power for 192 hours by a fuel cell system, and a silicon extraction experiment with its own heat rejection system. Let's now look in more detail at their lunar resource extraction hardware. Resources Blue plans to extract from lunar soil. Blue is focused on three key resources initially. Those are oxygen, silicon, and aluminium. Let's look at those and a few other possible resources that could be produced using their hardware. Oxygen. In April 2026, Blue Origin posted on X about its Air Pioneer technology. The hardware consists of a reactor, shown on the left, that melts lunar regolith. This releases oxygen and other gases, which are then piped into a purification system on the right to produce medical and propellant-grade oxygen. Blue Origin describes the system as highly efficient, with a stable, continuous reactor design that can support long-duration operations and the production of significant quantities of oxygen. However, the process requires very high temperatures and would need a substantial power source to operate at scale. Silicon. In 2023, Blue Origin demonstrated a solar cell and transmission wire made from lunar simulant material. This proved power generation systems can be made directly from lunar materials. Silicon and aluminium are abundant everywhere on the lunar surface, allowing for easy manufacture of solar panels and wires once the necessary technology is deployed. Blue Origin's hardware deployed at scale would eliminate power constraints and support a large, thriving moon base complete with processing facilities and habitation modules. Silicon can be reduced to more than 99.999% purity, high enough for efficient solar cells. To protect the cells from the harsh lunar environment, they would need a cover glass. Because glass is silicon dioxide, it can be manufactured using lunar-derived silicon and oxygen. This lunar glass could protect solar panels and also be used for windows in habitats. Looking at Cislunar Industries' Lunar Forge plans, oxygen removal is a key step in metal production. Pairing their hardware with Blue Origin's ISRU plant would reduce the energy requirements of metal production and enable a wider range of metals to be produced on the moon. The graphics from Cislunar's Lunar Space Foundry show slag as a possible input to their system. The foundry is designed to output rails, beams, sheet metal, cables, wire, and even mining equipment. Hydrogen. While Blue doesn't specifically mention hydrogen, it would be one of the volatiles released from heating lunar soil. Capturing, purifying, and liquefying hydrogen would enable refueling of Blue's Mark II lunar lander, as well as other vehicles or fuel cell systems on the lunar surface. It's not clear whether sufficient hydrogen could be captured from lunar soil close to the landing site, or whether it would be necessary to extract hydrogen from permanently shadowed regions which are suspected of containing significant quantities of lunar water ice. Metals. Blue plans to directly produce iron and aluminium from lunar soil. In addition, by selling their deoxygenated slag to other startups, more metals could be extracted. For example, Cislunar Industries has plans for a lunar foundry. Slag from Blue Origin's ISRU plant would make a good starter material, as the oxygen would have already been removed, eliminating an energy-intensive step, since most metals in lunar soil are chemically bonded to oxygen. Final thoughts. Blue Origin's vision for lunar resource production supports low-cost lunar and cislunar transportation, human lunar settlements, and deep space exploration. It could also provide abundant breathable oxygen and metals for power distribution and construction. The company envisions refueling and resupply stations supplied with lunar resources, and later with asteroidal materials. Blue Origin is not limiting itself to propellant production. It also plans to produce metals for construction and electronics, glass for windows and solar panel covers, and regolith-derived materials for roads and landing pads. Blue Origin estimates that its ISRU technology could reduce lunar landing costs by up to 60% and cut the mass of fuel cell and battery systems by up to 70%. Their Blue Alchemist team operates from Blue Origin's Space Resources Center of Excellence in Los Angeles, the world's largest dedicated facility for space resource prospecting and utilization. The campus spans 3 acres and includes 60,000 square feet of lab space, with over 65 experts across multiple disciplines working on this technology. It's hard to think of any company with the expertise, facilities, and funding of Blue Origin. The company has end-to-end capabilities for human exploration and settlement of the moon and beyond. From heavy and super heavy launchers to lunar landers and ISRU hardware, they have the complete set of hardware needed to turn their vision into reality. Blue Origin could be a key partner for many startups, either by supplying inputs to their processing operations or providing raw materials for construction. The company has also indicated it would be open to purchasing propellants produced by other lunar operators. What do you think of Blue Origin's ISRU hardware and technology? Are they currently the world leader in ISRU development? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips and slides from this week's videos. It's a live Q&A on this week's space topics where I read out some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.